Hey there, Ken here again from No Brainer, and we're back today to bring you another GMAT quantitative exercise that I think if you're preparing for the GMAT you might find helpful. So without further ado, let's get right down to it. Okay, so let's get right down into the problem. This is actually coming from Manhattan Prep, which is a great resource that I have my students purchase. And it's a problem-solving exercise in the quantitative section. Apologies for the small print, so let me read it to you so that it's clear as to what's going on here. The problem goes like this. A store sells a certain product at a fixed price per unit. At the product's current price, Q units cost a total of exactly $300. If the price were lowered by $5 from its current value, then Q plus 2N units would cost exactly $300. If the price were raised by $5, then Q minus N units would cost exactly $300. What is the value of Q? There are 5 answer choices, and you'll want to take note that they're all multiples of 10 in this case. Multiples of 5. 10, 15, 20, 25, and 30. So particularly for those of you who don't like algebra, you're probably looking at this exercise and thinking, oh no, this is not going to be fun. I'm going to, however, show you 2 solutions here and demonstrate to you that even an exercise like this can be a no-brainer. So follow through and pay attention to how I go about this. First, I'm going to show you the algebraic solution, and then I'm going to show you what I'm going to call a methodical guess and check solution. Okay? Let's get into it. Okay, so let's go back to the exercise. The store is selling a product at some price per unit. We don't know the price, but we know that they sell Q units, and the total cost is exactly $300. That means, so what we want to do is start writing equations down. Look at the relationships we have and start writing things down. So we know that there is some price P multiplied by some number of units Q, which is going to total $300. Now from the second sentence, we also know if the price were lowered by $5, or P minus 5, then Q plus 2N units would cost the same $300. So my price times my new quantity, which is no longer just Q, but Q plus 2N, is going to again equal $300. Right? Finally, the second part of the last sentence says, but if the price were raised by $5, we'd sell a different number of units, right? And it would again total $300. So what is that price and quantity? The price raised by $5 means P plus 5 multiplied by Q minus N equals $300. So we've got 3 equations right now. We happen to have 3 unknowns, so we should recognize that with this information we should be able to come to a conclusion, remembering we're looking for what is Q. So now that we have that, what I'm going to do is we're going to try to manipulate these equations and see what we come up with. So the first thing I'm going to do is I'm going to multiply these two binomials together, and recognizing that the left side is going to be PQ, and I know that PQ equals 300, so that probably will help me. So let's just start multiplying that out. The top one here, we'll call it equation 1, multiplies out to PQ minus 5Q, our inners, plus 2PN, our outers, minus 10N equals, now it equals 300, but I know 300 equals PQ. So I'm going to right away put PQ on the side here. Now I'm going to take my second equation and do the same thing. PQ plus 5Q minus NP minus 5N equals again PQ, right? Super. Okay, so this is looking really good because the first thing we might recognize when we observe these new equations is that we can knock out PQ here and here and here and here, right? We subtract PQ on both sides and those all go away. The next thing we might want to recognize is, remember when you learned the addition-subtraction method when you have two equations and multiple unknowns? Well, we're going to employ that here. We're going to add these two equations together because we recognize we have a minus 5q here and a plus 5q here. So if we simply now add down, this is going to wipe out. We are going to end up with positive 2 minus 1 NP, whether it's NP or PN is the same, right? So we've got basically plus 1 NP here minus 15N equals 0. Now from this point, what we can think about doing is factoring N out on the left side here, because both of these simple terms have an N in common. So let's pull an N out, which enables us to rewrite the equation like this. All right, so now we're really close. When we get to this point, we recognize that when we have something times something equals 0 in an equation, one way to deal with this is to set each of those two somethings equal to 0, okay, and see what comes from that, right? In this case, we actually have two variables, so one of them being N, one of them being P. So for this to hold true, either N equals 0 or P minus 15 equals 0, which means P equals 15. And if P was to equal 15, remembering that PQ equals 300, Q would have to be 20. And if I was running short on time, I would choose 20, which happens to be the right answer here for Q, and move on. But if you wanted to check it, all you need to do is go back to your equations. Well, 15 times 20 is clearly 300. Go back to these two equations, 1 and 2. Plug in P for 15, Q for 20 in both cases. Solve for N. And if N is the same value in both equations, you definitely have the right answer here. Okay? So that's the algebraic solution. Answer, Q equals 20. Well, that seemed like a relatively clean solution, right? I mean, it wasn't that difficult. The problem with algebra, though, in an exam like the GMAT, is if you start going down the wrong path, you can get yourself all fouled up and end up just putting yourself in a big time crunch problem. And we don't want that to happen. So you need to have more nimble, practical solution methods at your disposal. And what I want to do now is talk to you how actually I solved this the first time, which is more of a methodical guess and check. First thing, you've got to step back and recognize what's going on. You've got basically some price and some quantity, and they're represented in variables P and Q. There's also an N thrown in here, right? But the price times the quantity in all three cases equals $300. So something times something is always coming back to $300. So what I would do is I would just simply start cataloging first my P's and Q's that I'm going to try. Then I'm also going to write down my second set of relationships, which is reduce the price by 5 and raise the quantity to Q plus 2N. And then the other pair is to, that was to lower the price by 5. The third option now is to raise the price by 5 and lower the quantity to Q minus N. Now, we don't know what this N is, right? So that's one of the issues here. It makes the problem slightly tricky. So let's just start getting into it. We know that, so what, now we also know the answer choices are for Q, are 10, 15, 20, 25, and 30. Use that to your advantage. So I would start with a Q times, from there, times some P that gives you 300 cleanly, right? So let's start with the bottom, 30. Let's imagine we assumed that Q was 30, which would make P what? 10, right? Okay. So our hypothesis right now is answer is Q30. But what we need to do is run through the other variations that were provided for us that all should multiply to 300 and see if it all holds true. Now we have this N here, and the N is going to be the hook between all of them, because for this to work, the N must be the same value across all scenarios. So if P is 10 and Q is 30, in my second scenario, this new price would be simply 10 minus 5, or 5, right? Now, if the price was 5, and we need a quantity to get to 300, what is that quantity? Can you do it? It's simply 300 divided by 5, which comes out to 60, right? Okay. Now hold that thought. Let's move over here to P plus 5 and Q minus N. If the price was increased to $5, it would make it $15. Now, if the price is $15, what quantity would get me to $300? 15 times what makes 300? 20, right? Okay. Now, for this to work, the expression we have here and the expression we have here need to solve for 60 and 20 respectively, while giving us the same N value. The same N value must come out of this. Okay? So our original Q was 30, right? So 30 plus 2N equals 60, which if we solve for that, for N is 15. We do the same thing over here. Q minus N needs to equal 20. Our original Q was 30. 30 minus N equals 20. Solve for N equals 10. These do not match. Therefore, 30, our hypothesis 30 for Q is incorrect. Okay, so the N's didn't match, so we know the answer is not E. So guess what? We got to go through the process again. So I'm going to jump right to 20 for Q. And recognizing that 20 times 15 makes 300 very nicely. So if my Q is 20, that would make my P 15 in order to multiply to 300. So now my P minus 5 is 10. And to get to 300, my quantity value would be 30. Over here, P plus 5 is 20. My quantity value to get to 300 would be 15. Okay, so I can do the same thing now. We take this Q plus N with this 30 and quantity 20 and solve for N. So Q plus 2N, or 20 plus 2N, we hypothesize is equal to 30. That would make N equal to 5, right? Do the same thing over here. Q is 20. 20 minus n. Set now equal to 15. Do the math, solve for n. N equals 5. A match. And because those n's match, when we plug those values in, Q must be, in fact, 20. And there's our choice C. Okay, wow, that was a lot longer than expected. And if you made it all the way to this point in the video, congratulations. Sorry it took so long, but there was a lot to explain. There were a couple of different methods I wanted to convey. Hopefully you followed step by step and understood what was going on. Well, hope that helped. Hope that helps you solve other exercises like this, because you always want to be able to have multiple ways of approaching the same problem, right? You want to have the traditional method and a more practical type of solution, and be able to employ one or the other depending on what's going on. So thanks again. Contact me or comment if you want more explanation, and keep working at this, and you too can make GMAT a no-brainer. Till next time.